We will start today's class. Okay, as you can see that today's class is primarily your problem solving, right? Because we have already completed these two topics. When we talk about 6.1, so we have covered the basics of thermodynamics. We have covered the concepts such as what is the basic meaning of thermodynamics, what is system, what is surrounding, different type of systems, that is my closed system, open system, and isolated system. Then we have different type of properties, but before that we had state functions and path functions. So it's there, right? So we studied what is my extensive property, what is my intensive property. Then we studied about different type of processes. Okay, so when we talk about processes, the first categorization that we have studied was reversible and irreversible. So we have studied in detail what is the meaning of reversible process and what is the meaning of irreversible process. Then we studied that there are different type of subsystems depending on the path, which is either the path is taken at constant pressure, constant volume, constant temperature, or it's a cyclic. Okay, so according to that, we have isobaric process, isochoric process, isothermal process, cyclic process, and adiabatic process. So these five processes can be there in both reversible and irreversible processes. Then we studied what's the basic meaning of work, heat, internal energy, right? Then we studied that the formula of work was minus integration of P external to dV. Okay, so which is just the basic formula for work, be it reversible process or irreversible process, right? Then we have studied state function and path function. So this was the topic that was covered in 6.1. Okay, now when we talk about 6.2, we have studied about first law of thermodynamics. Okay, first law of thermodynamics. So when we talk about first law of thermodynamics, we have covered the concept of internal energy. Then we studied what is specific heat, heat capacities, what is Cp, Cv, degree of freedom, how Cp and Cv is related. Then what is your adiabatic constant. Then we studied first law of thermodynamics. And then after that, we derived the work done in all the processes using your first law of and basic minus integration of P dV. Okay, then we studied adiabatic process in detail. Now, the one topic that we've missed, okay, is this. It is the derivation of, or not derivation, it is the method to find CV. Okay, experimental method using calorimetry. Why I skipped this? Because this is not needed for JEE or NEET. Okay, this is something that you have to study in your school. Okay, so this will be taught in your school. There's a basic setup using calorimeter from where you can find CV of any object. Okay, so this is your theoretical topic which will be covered in your school. Okay, it has no significance as far as JEE NEET is concerned. Okay, everyone, are you able to hear me? Please join your audio. Just verify once. Are you able to hear me? Everyone should be able to hear me because I'm able to hear myself. Okay, audible. Okay, very good. And please message on host, not on co-host. Okay, message on host. So we have covered these topics till last class, right? We have covered these topics till last class. So those who are joining now, we just discussed that what are the topics that we have covered till last class. So today, before starting problem solving, we will see some basic differences between adiabatic process and isothermal process because we left that topic at last. Okay, right? Now, when you talk about adiabatic process, okay, so we have studied what's the formula of work done, what's the relationship between P and V, and what is the slope. Yes, tell me. Yes, So we have already discussed what is the difference between reversible process and irreversible process. Now, when I talk about reversible process, it's a slow process. So at every step, it is in equilibrium. So the pressure will change slowly. The pressure and volume will change slowly. So slope will be, or the graph will be something like this for reversible process. Yes or no? So this is the graph for reversible process. But when you talk about irreversible process, so in irreversible process, we assume that the pressure change, okay, the pressure change occurs randomly, okay, not randomly, suddenly, okay. So actually it won't be like this. It is just for assumption. Actually, it will be something like this. Okay, something like this, like it will change very fastly. Okay, got it? Now, I can say that if we talk about work done, okay, if we talk about work done for reversible process, it is this whole area, it is this whole area, okay, because pressure is changing at each and every point, and so is volume. But when you talk about irreversible process, so this pressure changed P1 from P2 almost instantaneously. So the area would be P2 into this volume. Yes or no? Right? P2 into this volume. Okay? Got it? Right? That's why when we talk about P external into V2 minus V1, right? I've told you in last class that this P external is taken as P2. So I hope now you understood what is this P external, why it is taken as P2, right? Got it, everyone? Okay, so this was the case of expansion because volume is increasing. Now case of compression, again the path will be same but the direction will be opposite, right? The direction will be opposite. So the graph will be something like this. This is for expansion and this is for compression. Now if you see the graph in reversible process, so have we seen this graph somewhere? Tell me, have we seen this kind of graph in some other process? Anyone? Tell me, have you seen this kind of graph between P and V? Yes, yes, OS, Samarth, right? We have seen this kind of graph in isothermal process also, है ना? In isothermal process, because for isothermal process, it was PV is equal to constant. PV is equal to constant, right? That's what we discussed in last class also. Last topic in last class was the relationship between slope of isothermal process and adiabatic process, or the curve of isothermal process and adiabatic process. Okay, so yeah, so this is the relationship, how the graph is. Now this was the last topic that we have studied, okay, that we have studied in last class. So it is comparison of isothermal process and adiabatic process. So if you see the graph, can you see the graph, right? If you see the graph, okay, now for expansion, right? For expansion, the graph is like this. Graph is like this. Okay, so the graph having more slope is isothermal, and graph having lesser slope is your adiabatic. Okay, now just see this point. This is one point where alpha is equal to 1 or P by V is equal to, or there is no change. Okay, so at this point, the slope will change at this point. If you see this point, okay, the slope will change at this point. So below this point, the slope of isothermal, right, at the same point, the slope of isothermal, okay, or when you talk about the angle of the isothermal is more than that of the adiabatic, right? But if you see this graph above that point, okay, or in case of compression, the above graph will be of adiabatic and lower graph will be of isothermal. Got it? Got it, everyone? So this is something that you have to understand and remember. Okay. So I can say that when we talk about expansion, okay, right? For expansion, if we have two curves, the upper curve will be of isothermal, and the lower curve will be of adiabatic. Okay, got it? Right? Now, when you talk about compression. So in compression, the above curve will be of adiabatic, and the lower curve will be of isothermal. So this is one of the most important concept that you have to remember. Okay, got it, everyone? Tell me, got it? Because see, if you consider the slope dp by dv is equal to minus gamma p by v, right? So obviously the sign will also depend now, right? Sign will also matter, right? If see, pressure is decreasing, the pressure is decreasing, volume is increasing, so we have different sign, right? But pressure is decreasing and volume is also decreasing, then also we have different sign. So I can say that in one case it will be more than that of the isothermal, in one case it will be less. Got it? Because we know that 3 is greater than 2, but minus 3 is less than minus 2. Got it? That's what will happen here, right? Right, everyone? Tell me, everyone got this concept? Yes? Okay. So just write this concept somewhere. This is very important. You are asked to find which of the curve is your isothermal process or adiabatic process. Okay? Okay. So we will solve one problem. Okay? Just try this problem, everyone. Just try this problem. Wait, I'll just show you. So yeah, so this is the problem. Okay, so this is the problem that we have here. So I hope everyone is able to see the problem, right? So you have to find the work done. Okay, you have to find the work done. Now, first of all, tell me, this is the curve between T and V, not P and V. That's the first thing, right? This is the graph between T and V. Okay, so you have to find the work done. Everyone, try to solve this problem. What kind of process is this? First of all, you have to think what kind of process is this. Okay, you have to find work done for BC first. BC. Okay, so for BC, you have to think what kind of process, overall process. Okay, work done in BC, CA, and BA. Then you have to add. Okay. Yes, Abhiram, it is a cyclic process. Okay, it is a cyclic process. Yes, the answer is 800. Okay, the answer is 800. 800 calories. Okay, very good. So, can anyone tell me how to solve this? Wait, I'll mute. Jitendra, I'll mute you since you have answered. Okay, explain how to solve this.
Hello, sir. Hello, sir.
Tell me how to solve this.
Sir, for cyclic process, we'll take as du is equals to 0.
Why?
Sir, sir, delta u is equals to 0. We'll take, sir.
Why it will be zero? Thermal process now. Tell me why it is zero.
Sir, it's cyclic process.
Okay, so what happens in cyclic process?
Delta u will be 0, sir.
No, I'm asking why delta U will be zero in cyclic process. Why not delta Q?
Sir, because q we have to find for work, no, sir. So that's why q will be minus
No,
w.
but why in cyclic process delta U will be zero? Why delta Q cannot be zero? My question is this: why delta U will be zero in cyclic process? As simple as that. Tell me. Jitendra, tell me. Can you answer? Okay, so I guess. Okay, Srihari, I'm unmuting you. Srihari, I've unmuted you. Okay, can you explain how to solve this problem? Who can explain? Tell me, who can explain? Okay, I guess there's some issues. So see, as we know in cyclic process, right? The starting point and end point is same. Okay, the starting point and end point is same. Yes or no? Tell me. That's what happens in cyclic process. The path doesn't matter whatever the path is. The starting state and end state are same. So if starting state and end state are same, okay, right? If starting state and end state is same, okay, got it? Then I can say that delta U, the basic formula of delta U was NCV delta T. This is my basic formula. Yes or no? Tell me. Yes or no? Yes? Okay. Got it, everyone? Right? So I can say that since the state is same, since we have both initial and final state same, okay, then I can say that NCV same T minus T will be zero, right? That's why for cyclic process, delta U is always zero. Okay, delta U is always zero. Okay, okay, yes, very good. Now, when we talk about work done, it will be work done in BC, then CA, then PA. Okay, now Q is also given. Q is also given. So I can say that since delta U is zero, so we know that delta U is equal to Q plus W. Okay, Q plus W. Yes or no? Right? So Q is equal to minus W in case of all the processes. Yes or no? Tell me, yes or no? Right? So work done should be minus Q, right? Work done should be minus Q. Now, in this problem, it is already given. It is already given that you have to calculate the work done in process BC. Okay, if total 600 calorie of heat is released in whole process. Okay, so this is your BA. BA is your isochoric process. So no work is done in BA. So BC and CA, right? Got it? So I can say that work done total is work done in BC plus work done in CA plus work done in BA. So work done in BA is 0. Got it, everyone? Work done in BA is 0. So you just have to find work done in BC plus work done in CA, right? Okay, and this should be equal to Q, right? This should be equal to Q. So work done in BC should be equal to, right? Got it, everyone? So see this, right? Okay, everyone, can you see this? Yes. So since Q is equal to minus W, this Q is equal to minus this that we have solved, right? Now Q is already given, है ना? Because it is said that 600 is released, right? Released means it will be negative. Got it? So you have to understand the problem very clearly. That's why it will be minus 600. Okay, it will be minus 600. Okay, minus 600. Work done by BA 0, as I have told you. Work done in AC. AC. So you can find what is the work done in AC. Okay, which is minus 2 into 400 minus 300. Okay, got it? Because pressure is constant, na? So we can find, right? Then work done by CB. So you can easily calculate work done by CB by taking this to that side. Okay, everyone, got this problem? Tell me, got this problem? Everyone should get it, right? Everyone should get it. Okay, how come WAC is equal to 2 into 400 minus 300, right? Everyone should get it. Why it is 2? So you should start with basic formula. Work done is minus P external into V2 minus V1. Okay, you should start with basic formula. Okay, now here, why we have taken T2 minus T1, right? It is T2 minus T1, na? T2 minus T1, right? So we know that we have NR T2 minus T1, right? ये भी तो formula होता है, because PV is, tell me, P is a constant, right? Slope है ना? TV slope है. It means P is constant. P is constant. So this can also be written as this. ठीक है? And NR. N is 1 and value of R. Right? Now see, everything is in calorie. This energy is in calorie. है कि नहीं? This is in calorie. So if this is in calorie, R will be 2 calorie. Right? Got it? है ना? R का value calorie में 2 होता है. In case of joule, it is 8.314. Okay, got it, everyone? Okay, ठीक है? So I hope all of you understood this problem. कि कैसे क्या हुआ? ठीक है? And please be honest with yourself. If you don't get anything, just ask. Okay? Because you're trying to learn, right? Okay. Okay. ठीक है? So I hope you have clear concept about this problem. Yes? Everyone just raise your hand. If you understood how to solve the cyclic process, work done in cyclic process, just raise your hand. Okay? Okay, very good. Preetham, you understood? Jitendra, how you got this answer? Tell me, because you haven't solved it. That's for sure. Okay. Okay, everyone. So I guess all of you have understood this problem. ठीक है? Now we will solve some problems from our module. Okay. Okay. ठीक है. So I guess we have already discussed in class of 6.1. Tell me, we have already discussed in class of 6.1 except 14, 15, 16. Yes or no? Tell me. Have we discussed 6.1? ठीक है. So let's see how many of you tried solving homework of 6.1. First of all, we will discuss 6.1, then we will discuss 6.2. Okay, got it everyone? So 6.1, anyone have any doubt from 1 to 5? Tell me, anyone have any doubt from question number 1 to 5? Tell me everyone, 1 to 5. No doubt? 6.1, I'm not getting any messages. I guess 1 to 5 is easy. All of you should be able to solve this. Okay. Now 6 and 7, anyone? 6 and 7, tell me. Any doubt in question number 6 and 7? 7. Okay. So see, question number 7, we have basic formula putting and getting problem. So the external pressure needed to compress an ideal gas from 22 dm³ to 8 dm³. We know that 1 dm³ is equal to 1 liter. As simple as that. Okay, right? 1 dm³ is 1 liter. So this is basically 22 liter to 8 liter. Okay, but since the work is done in joule, kilojoule, right? You can take in meter, SI unit, because the answer is also in SI unit. Okay, got it? Now, work done is given by minus P external delta V. Now, delta V is, so final is 8. So 8 into, and we know that 1 dm³, 1 dm³ is equal to 10 to the power minus 3 meter cube. Okay, got it? 1 dm³ is equal to 10 to the power minus 3 meter cube. Okay, got this everyone? So 8 into 10 to the power minus 3 minus 22 into 10 to the power minus 3. Right? Now can you solve? W is given, the external you have to find. Just solve this. So it will be 4.2 into 10 to the power 3. Now this is 10 to the power minus 3. So we'll take to this side 10 to the power minus 3 into, now 8 minus 22 is 14 minus 14. So minus minus plus. So it will be plus 14. 14. This is equal to the external. Can you solve this now? Tell me. 42 by 14. Can you solve this? It is almost equal to 3. It is equal to 3 actually. Anna, right? Got it everyone? Easy? Okay. Shreya, Suhas, got it? Okay. Now question number 8 to 12. 8 to 12. Anyone have any doubt between question number 8 to 12? Tell me. 8 to 12. 10th. Okay. Before 10th, no doubts. So question number 10. See question number 10, everyone. The work done in ATM liter. Okay. When 3 moles 3 moles of ideal gas expanded from 15 liter to 30 liter against constant pressure of 76 centimeter. ठीक है? At 27 degrees centigrade. Now ask yourself, what we have to do here? Think about this. Okay? 3 moles, n is equal to 3 is given. N is equal to 3 is given. ठीक है? V1 is 15 liter. V2 is 30. Sorry guys, my internet from phone got disconnected. Just wait for 2 minutes. Okay, yeah, it's back, right? So 15 liter, 30 liter. Now external pressure, the external is equal to 76 centimeter, which is basically 1 atm, right? This is your 1 atm. 1 atm. And temperature is also given, which is 27 degrees centigrade or 300 Kelvin, right? Now, basic formula of work done. Basic formula of work done, right? But this is your isothermal process. Okay. Then tell me what you have to do. Tell me. Tell me. See, this is very simple concept. Doesn't matter. First of all, doesn't matter what is given. It is said that constant pressure. It is said that it is a constant pressure. So we know that if it's constant pressure, then the work done is always minus P delta V. Yes or no? Tell me. Yes or no? Tell me. Right? Because P will be taken outside your integration because it's constant, right? So it is just your formula putting getting problem because P is given 1 atm and V1 minus V2, sorry, V2 minus V1. So we already have the answer, which is 1 into 30 minus 15. Got it? Right? So we have minus 15 atm liter. So the answer is B. Got it, everyone? Tell me. Got it, everyone? Okay. See, the first step should always be identify the process. Identify the process. Okay. So if it's constant pressure, doesn't matter which process it is, reversible, irreversible. Okay. It is always P delta V. Okay. So question 11. Now see question 11. What is given in question number 11? Fe solid is dissolved in aqueous HCl in a closed vessel. The work done is. Now tell me, closed vessel. So closed vessel, if we are talking about closed vessel, right? Volume will change, yes or no? Tell me, volume will change when it's a closed vessel? No. So if volume will not change, then what will be the work done? Zero. Okay? Got it? Right? Got it, everyone? Okay. Till 12th, till question number 12, any more doubts? Till question number 12, any more doubts? Okay. Question number 12. What is the doubt in question number 12? What is your doubt in question number 12? Tell me, guys, what is the difference between question number 12 and question number 10? It is said that work done when ideal gas is compressed isothermally by 1 liter, right, against a constant standard atmospheric pressure. So again, standard atmospheric pressure, which is constant. So formula of work done is always, right, minus P delta V. Got it? Right? Now it is compressed. Compressed means volume is getting less. So delta V is negative. Delta V is negative. And how much? 1. So delta V is minus 1. It is given as simple as that. And P, atmospheric pressure, which is also 1. So W is equal to minus 1 into minus 1, which is 1. As simple as that. So इसमें क्या नहीं समझ में आया? Tell me, right? Now this one is ATM liter, है ना? ATM liter. और यहाँ पे आंसर क्या दिया हुआ है? जूल में, right? See, this one will be ATM liter. Answer क्या है? जूल में. So we know that in order to convert ATM liter into joule, याद है? कौन सा multiplier था? 101.3. याद है? In order to convert ATM liter into joule, multiply your answer with 101.3. Got it? ठीक है? As simple as that. Right? So what will be the answer? It is this, because it is your kilojoule. ठीक है? Got it? Okay. So next, 13 to 15 or 13 to 16. Okay, we will see. Abhiram. ठीक है? Question number 13 to 16. Tell me. Question number 13 to 16. Okay, before 14. 13 everyone solved. Tell me. 13 everyone solved. 16. Okay. So 14, 16. Okay, so first we will solve question number 14. Okay, so first we'll solve question number 14, then 16. Okay, okay. Now we will just see question number 14. See, everyone, can you see question number 14? So this is your question 14. Now what is given? At constant temperature. So temperature is constant. So T is equal to 300 Kelvin. Write down all the information first. 1 mole of gas. So N is equal to 1. Expanded reversibly, right? So it's expansion and it is reversible process, right? V1 is 2. Okay, and then V2 is 10. Now tell me, okay, now tell me that what will be the formula? Which kind of process it is? Tell me, which kind of process it is? Because first step is identify the process. Isothermal, yes. Reversible or irreversible? It is already written that it is your reversible isothermal expansion. Okay. So what is the formula for work done? Tell me. Second step, write the formula. What is the formula? Minus 2.303 nRT log V2 by V1. So 10 by 2. Got it? Got it, everyone? So which is minus 2.303 into 1 into 8.314 into 300 into log 5. Got it, everyone? So log 5 is given. Just put the value, get the answer. Yes or no? Now, there's one thing that you should know, okay, how to solve this problem. The value of R can also be taken as 25 by 3. Okay, 25 by 3 can also be taken as 25 by 3. Got it? Got it, everyone? So it will be minus 2.303 into 1 into 25 by 3 into 300 into 0.7. Right? Now it's easy. Can you solve this? 100. So if you solve this, you will get your answer, which is almost equal to approximation, right? I'll be doing approximation. So it is 2.3 and then 0.7. Okay, right? So 2.3, 0.7, this 100 will get cancelled. So 23 into 7 into 25, as simple as that. Okay, 23 into 7 into 25. Okay, got it? So after solving, it will be somewhere around, yes, Pranjal, 4,000. It will somewhere around 4,000. Got it, everyone? Right? So this was your basic formula putting getting, right? Basic formula putting getting. Okay, so after question number 14, we have question number 16, right? Question number 16. Let's see question number 16. So I hope everyone understood this. Yes. Okay. So we have question number 16 over here. Now, in this problem, first of all, as always, write down the information. Write down the information. Whenever you solve a problem, write down the information. Okay. So 1 mole of gas, N is equal to 1. Compressed. So obviously V2 will be less than V1, but still we will write from 500 centimeter cube. Compressed from 500. So from means it is V1 centimeter cube, right? So it is, so we can convert later. Then we have at a constant pressure. So P is constant, which is 1.216 into 10 to the power 5 Pascal. So see, here we have to convert units. Okay, now work done is given. What is work done? Work done is 36.5 joule. Okay, fan volume of the gas. So basic formula putting getting, right? This is also your basic formula putting and getting. Now the only issue is conversion of units, as simple as that. The only issue is conversion of units. So work done is equal to minus P external into V2 minus V1. Yes or no? Tell me, yes or no? Now this work done is already in joule. So we have to convert. Now this pressure is already in Pascal. So no issues. This is already in Pascal. Now you have to convert this into meter cube. So we know that V1 is equal to 1 centimeter cube is equal to 10 to the power minus 6 meter cube. Yes or no? Right? 1 centimeter cube is equal to minus 6 meter cube. That's it. So it will be 500 into 10 to the power minus 6 meter cube. Right? You just have to put the value, get the answer. So let's see. Let's see. So it is 36.5. Now we will divide this P, which is 1.216 into 10 to the power 5 is equal to minus V2 minus V1. So V2 minus V1 is, so it is 5 into 10 to the power minus 4. Yes or no? Tell me, everyone. Yes or no? Now you will just have to calculate this, right? If you calculate this, okay, you should get the answer. Abhiram, is there any issue in this? Because it is just your calculation. Okay, it is just your calculation. So if you see this, 1.2, 3.6, right? 1.2, 3.6. So it is 3 times, or it is actually 30 times. Okay, so this is actually your 30 into 10 power minus 5, or okay, and this is equal to minus V2 plus this is your 50 into 10 power minus 5. So this will go this side, this will go this side. We will solve. So V2 will become 20 into 10 power minus 5 liter, right? Which is equal to 200 centimeter cube. Got it, everyone? So the answer is D, right? Got it? So I hope all of you got this problem. Tell me. Okay, very good. Now, after this, question number 14. After question 14, so we will solve question number 17 also. Okay. So all of you who didn't solve question number 17 till now, please solve question number 17. We will try to solve question number 17. Okay, got it? Because we have already solved this kind of problem. Okay. So everyone, just go through problem number 17. Because it seems big, but it is a very easy problem. Okay, all of you, can you see problem number 17? Yes? Are you getting the concepts? Tell me. Everyone is getting the concepts now? If you have any doubt, please ask. Anjali, Mansi, Anagha, Jasharan, Imba, Karishma, Koshi, Kushi, everyone is getting? Okay, very good. So try to practice more and more problem. If anyone is having RC Mukherjee, please send the scan of examples. Okay. Who's having RC Mukherjee? Because my RC Mukherjee was with some student, and I don't remember who that student was. Okay, Jasharan, just take the scan of examples. It might be 4 or 5 pages, and just send that. Okay, because in RC Mukherjee, most of the problems are thermochemistry. Okay, just send this kind of examples. Okay, chalo. So we will see how to solve this problem number 17, right? So first, you have to understand the problem, what is given and what process we have. Now, first of all, I would like to ask you that we have 3 steps. Yes or no? 3 steps, right? This is a cyclic process. Yes or no? This is a cyclic process. Is this a cyclic process? Yes. Okay. This is your cyclic process. Now, second, overall cyclic process. But when you talk about, suppose this is your, wait, this is your path 1. This is your path 2. And this is your path 3, right? Path 3. I'll just write 1, 2, 3. So what is path 1? What is path 1? Which process is path 1? Yes, very good. So path 1 is your isothermal process. Okay? Path 1 is isothermal process. It is given. It is already given. So you might be thinking, how can we say that it is isothermal? Why not adiabatic? So it's given. It should always be given. Path 2 is your isobaric. Very good. And path 3 is your isochoric. Yes, very good. So first we know that it is your isothermal, isobaric and isochoric process. Okay, right? Now, so we have to solve this problem. First one, we'll start with first one. So when you talk about first one, the gas expands isothermally to 2V naught while heat Q flows into the gas. Okay, okay, right? So it is your isothermal process. You have to find what? You have to find work done. So let's see, and you have to find work done in every step. So work done in first. So work done, right, in first process, W1. So it is your isothermal process. So just write down the formula of isothermal process. So it is minus nRT ln. See this, I'm writing ln because I don't have to find the value. I just have to write, okay, the expression. So ln, V2 minus V1. Got it, everyone? Everyone got this, right? As simple as that. That's it. Khatam ho gaya. So we know that minus n is 1, r is 25 by 3, right? R 25 by 3 or 8.314. You want to write anything? T. Now T. What is T here? What is T here? Tell me. What is T in step 1? It is given, right? If you see the graph, it is given. It is T naught. Yes, T naught. Log base E. I'm just in habit of writing log, so I've written log base E, or you can just write ln. It's fine. V2 by V1. What is V2? V2 is 2V naught because it is expansion. So V2 is 2V naught. So 2V naught divided by V1 is V naught. V naught. Got it? Got it, everyone? Okay, right? So this is your log 2 base E. So the answer is minus 25 by 3 T naught log 2 base E. Okay, right? Got it, everyone? Okay. Or if you want to find the value, it will be minus 25 by 3. Now log 2 base E is 2.303 into log 2 base 10. So ln 2 is equal to 2.3 into 0.3. Again, 2.303 into, tell me, log 2, which is 0.3. So ये हमेशा आता ना, ln 2 is 0.69. So ये 7 कर दो, कोई दिक्कत नहीं है, ठीक है, 7 कर दो, कोई दिक्कत नहीं है, right? So this is actually into 7 by 10 T naught. Yes or no? Tell me, yes or no? So ये गया 5 से, ये गया 5 से 2 times. So it is 35 by 6 minus 35 by 6 T naught. Okay, got it? Okay. Okay. So this is your first problem. Heat is given to the gas, as simple as that. When an object will expand, when heat is given to the gas, na? Question number 2, right? Let's see question number 2. Okay, question number 2. First ka second. Second. Now the gas is compressed at a constant pressure back to the original volume, which is your step 2. Okay, so work done in second process. Tell me, what is the formula for work done in second process? Tell me. Yes, exactly. So minus P delta V, V2 minus V1. Simple, as simple as that. So P is already half P naught, half P naught. What is V2? V2 is V naught, V naught, and V1 is 2 V naught. So this is your half P naught into V naught. That's your answer. Got it, everyone? Tell me, everyone got this? Right? And last is 0 because it is your isochloric process. Now tell me, was this a difficult problem? Was this a difficult problem? Right? Okay. Okay. So we have discussed this problem. So question number 17 done. So we are done with, yes, only formula putting it in. So we are done with 6.1, right? So 6.2, which module it is negative? Answers, if it's something else, you can just correct it. Okay, it's fine. Okay, Pranjal? Because you have to believe in your concepts now. It is minus P into delta V. If it's compression, right, then work done on the system or work done is always minus P external into delta V. So it will be positive value, right? So see, when we talk about 6.2, we have already covered these topics. What is internal energy? What is first law of thermodynamics, right? Now, this is one simple topic which I skipped. What is enthalpy? Okay. Now, enthalpy is same as energy. Okay, enthalpy is same as energy. Or you can say that it is everything. Okay, it is every energy, right? Associated with internal energy and change in work done as well as change in pressure. Okay, okay, everyone. Okay, so yeah, so the formula, the basic formula of enthalpy is this: H is equal to U plus PV. H is equal to U plus PV, right? Now, how this is different? How H is different from Q? Now, just see. This is H, enthalpy, and enthalpy of any object can never be calculated. It is just change. So if you think about change, it is delta H is equal to delta U plus delta into PV. Yes or no? Tell me. Yes or no? Right? Got it? So this can be written as delta H is equal to delta U plus. Now since we have two terms here, so we will have partial. So it is V into delta P plus P into delta V. Got it? Tell me. Got it? Now, can you say that this delta H is equal to Q? Can you say that? Tell me. Can you say that this delta H is equal to Q? No, right? Because of this additional term, V delta P. Got it? Right? But when we talk about isobaric process, this is 0. This is 0. So in this case, in isobaric process, delta H is equal to delta U plus P delta V. Right? Got it, everyone? Yes or no? Got it? Right? And this P is P internal. This P is P internal. That's why we have positive charge over here. So don't worry about that, because this formula will be same for both physics and chemistry. So in this case, this delta U, sorry, this delta H is equal to Q. For which process? For only isobaric process. Okay. And in general, I just see this. In general, delta H is equal to NCP delta T, right? Because here pressure is constant. है ना? Pressure is constant. Got it, everyone? Right? ठीक है? So delta H is equal to delta Q at isobaric process, and delta H is equal to NCP delta T for all the processes. ठीक है? Now, what if we have change in number of moles? So we know that PV can be written as nRT. So change in PV can be written as change in delta Ng. So this is the formula that will be used a lot. Okay, PV is equal to nRT, right? So delta PV, if temperature is constant, right? If temperature is constant, the delta PV can be written as delta N RT if temperature is constant. And this N should be gases only. Okay, got it? So you can just replace delta P with delta NGRT. Okay, anyone have any issue in this? No? ठीक है. Okay. So we discussed calorimetry. Q is equal to C delta T, delta U, delta H. We have studied. Heat capacity we have studied. Delta H is equal to dq at constant pressure. We already studied that. Relationship between Cp and Cv. What I have talking about, Jitendra, Ng is number of moles of gas, N is number of moles, G is gas. Okay, so we have talked about these formulas. Okay, so this is the formula for work done in case of adiabatic process, right? So we have solved. Okay, so have you gone through the illustration? Tell me, everyone. I hope all of you have gone through illustration. It was given as homework. Tell me, how many of you went through illustrations? Okay, very good. So I hope all of you went through the illustrations and you have understood everything, right? Anna? So we'll start with in-class exercise, right? We'll start with in-class exercise. Okay. So in-class exercise, question number 1 to 5. Everyone, in-class exercise, question number 1 to 5. Any doubts in question number 1 to 5? Tell me. Any doubts? Question number 1 to 5. 5. Okay. Before 5. 3. Okay. So C, right? 3. Okay. We will solve C. Now question number 3. We'll see question number 3. If we talk about question number 3, right? Everyone, just go through question number 3 first. Right? Everyone read the problem? Okay. See question number 3. First of all, you have to know what is given as usual. Okay. Now, if you remember, we have solved one example. What is density of water? We know that density of water is 1 kg per liter. Yes or no? Tell me, right? We have already solved one problem in which we have used this concept that density of water is 1 kg per liter. So temperature of, sorry, weight of water is 2 kg. So volume is 2 liter. Okay, got it? Now the amount of heat supplied. Okay, the amount of heat supplied. Okay, this is basic formula. Okay, this is basic formula putting it getting. Okay, so the formula for heat capacity, if you remember, we have studied Q is equal to, or delta H is equal to, Q is equal to NC delta T. Yes or no? Tell me, NC delta T or MS delta T. How many of you remember this? Tell me. Tell me how many of you remember this? We have studied this now. Agni. Got it? Right, everyone? Okay, so here you have already given mass, which is 2 kg, mass 2 kg, right? But this specific heat constant is given in gram. So we will take this weight in gram. So 2000 grams. Okay, temperature change is already given, na? Right? Temperature change. ठीक है, which is, tell me, boiling, which is 100 minus it is already at 25, है ना, so it will be 75. Got it everyone? Yes, Pranjal. Now S is also given. What is S? S is 4.2. S 4.2. Now can you find Q? You just have to use this formula, ms delta T. Got it? Everyone got this? Just use ms delta T, you will get the answer. So the answer will be, so Q will be equal to 2000 into 4.2 into 75, right? And the unit will be kilojoule, sorry, joule. So if you calculate, you'll find the answer. So the answer will be, wait, around, it will be 630 kilojoule. Okay, if you calculate it, 4.2 into 2, 8.4, now 8.4. So it is almost 8. So 8 into 8, 64, right? And one decimal is replaced by this one decimal. Okay, right? And it is 80 into 80, so 2 decimals plus 2 decimals, 4 decimals, right? So, or sorry, 4 zeros. So kilojoule 30 plus 1 0. And since we have taken an approximation, so the actual answer would be around 630. Okay, got it, right? Everyone got this problem? Question number 3. Then question number 5. Everyone got question number 3 na? Okay. Now question number 5. See question number 5. 2 moles of idle gas expanded from 2 liter to 20 liter at constant pressure. Simple hai na? Basic formula putting getting, right? It is basic formula putting getting. Yes or no? We know that delta U is equal to Q plus W. Yes or no? Tell me, right? Calculate W, है ना? Calculate W. So W is equal to what? W is already minus P, which is 2.5. V2 minus V1. ठीक है? This is na. This is your Q, right? It is, if the system is supplied with 500 joule of heat, means it is given, right? Got it? So W, first of all, find W. So 20 minus 6. Okay. Now this is an ATM liter. You have to convert this in joule. Before adding, you have to convert this in joule. Okay, that's the concept, right? Got it? Everyone got the concept? So work done. First find work done. So it will be how much? 2.5 into 20 minus 6. So it will be 14. 14 into 2.5. So it will be how much? 28 plus 7, 35. So it will be minus 35. Minus 35. ATM liter. In conversion, right, we have to multiply by 101.3. Right? So it will be how much? So around 350, 360. Around 360. So it will be exactly 358 something. Okay, or just consider it 101. So it will be 355, right? 101. Okay, 101.3. It will be 355 minus joule. Got it? Okay, sorry, one more little. है ना? ठीक है, right? So it will be around minus 3.55 kilojoule. Now work done is given, heat is given. You have to find internal energy. Can you find internal energy? Tell me. Can you find internal energy? It is 5000 joule and it is supplied. Okay, so it will be positive. So delta U is equal to, in kilojoule it will be 5, in kilojoule it is minus 3.55. So the answer is 1.4 45 kilojoule internal energy. Got it? So what's the answer? See, what's the answer? The answer is C, right? Got it, everyone? Okay. Now, 5 done. 6, I guess you can solve. 6 is same as 5. Okay, 6 is same as 5. Now 7 to 10, 7 to 9, 7 to 9. Tell me, 7 to 9. I guess 7, 8, 9. All of you can solve now. Yes or no? I just discussed. So 7, 8, 9. Can you solve? Message everyone. Yes or no? 7, 8. Okay. 9th. 9th में क्या दिक्कत है? क्या दिक्कत है? Find the temperature at point A. Basic formula putting getting. A पे प्रेशर पता है, वॉल्यूम पता है, 1 मोल पता है, ठीक है? So PV is equal to nRT. इसमें तो थर्मोडायनामिक्स कॉन्सेप्ट नहीं लगेगा, राइट? पुट करते रहो ना. T is equal to PV by NR, राइट? A पॉइंट के लिए A का P और V डालो, B के लिए B और C का डालो, B के लिए B का P और B डालो. Okay, as simple as that. फिर A का पता हो गया, B का पता हो गया, C का पता हो गया, ठीक है? तो डिफरेंस ले लो. ओवरऑल क्या होगा? डेल्टा U निकाल लो, ठीक है? वर्क डन पता है ना? वर्क डन क्या होगा? इस केस में 0, इस केस में ये पूरा, राइट? ये पूरा वर्क डन निकल गया, ठीक है? तो हो गया, राइट? बिकॉज वर्क डन, ठीक है? यहाँ पे टेम्परेचर पता है, मोनो एटॉमिक गैस पता है, एरिया से वर्क डन निकल गया. सो वी नो दैट Q इज इक्वल टू U minus W. So U is NCV dt, NCV delta T. So overall process के लिए delta T निकल जाएगा. Yes or no? Right? हो गया, निकल जाएगा फिर. Any issues in this? And यहाँ पे तुम A और C का पहले टेम्परेचर निकालो तो सही. Who knows? सेम आ जाए, सेम हो जाएगा तो क्या हो जाएगा? 0 हो जाएगा. So Q will be just minus W. Right? Got it? Okay. STP at A. अब तो ठीक है ना? STP तो कैलकुलेट करने की जरूरत ही नहीं है. 273 केल्विन ही आएगा, राइट? हाँ, STP ना 180 into 2.7, so it is 273 केल्विन. सेम आ जाएगा, ठीक है? चलो, और यहाँ पे भी सेम आ जाएगा, दिमाग लगा लो ना, राइट? बिकॉज प्रेशर हाफ हो गया, वॉल्यूम डबल हो गया, तो रेशियो सेम है. तो C और A दोनों पे सेम टेम्परेचर होगा, 273 273. सॉल्व करना भी नहीं है. तो A और B सेम, सॉरी A और C सेम, राइट? और B पे क्या होगा? टेम्परेचर, वॉल्यूम डबल हो गया, प्रेशर सेम है, तो टेम्परेचर भी डबल हो जाएगा, है कि नहीं? तो डबल क्या होता है 273 का? 546. कैलकुलेट नहीं करना है तुमको, दिमाग लगाना है. हो गया. 9, 10 to 15, 10 to 15, right everyone? 10 to 15. Any doubts? टेन टू 15 पे डाउट है पूछो. फोर्टीन, ठीक है? 14 से पहले 13, 14. Okay, let's see. Question number 13. Consider a system consisting of 1 mole of diatomic gas. Right, everyone? Just go through the problem. 13, 14, 15. Okay, right? और कोई है उससे पहले वाला? बता दो. 10, 11, 12 हो गया? 10, 11, 12 नहीं हुआ, कोई दिक्कत नहीं है, बताओ. ओके पहले क्वेश्चन में 13 देखते हैं. Now see question number 13. See question number 13, right? So write down the information. N is equal to 1, diatomic gas. So Cv is equal to how much? Tell me. Cv is equal to diatomic के लिए Cv वैल्यू कितना होता है? 5/2. Yes or no? 5/2, right? R. What is the temperature? Change of gas if Q is given, W is given. ठीक है, right? So we know that delta U, formula putting it in, delta U is equal to Q plus W. Yes or no? And this is equal to N CV delta T. As simple as that. हो गया. Now यहाँ पे ये क्या है? Q कितना दिया हुआ है? Q is 50 joule and W is minus 100 joule. This is equal to N कितना है? 1 into CV कितना है? CV is 5/2 into R का वैल्यू कितना होता है? 25/3. R is 25/3. जूल में 8.314, so 25/3. ठीक है? So this is 25/3 into delta T. Delta T. ठीक है? So यही पूछा तुमसे. निकल जाएगा? Tell me, निकलेगा? Right? ठीक है? So if you solve this, it will be how much? Delta T will be equal to minus 50 into 6, whereby 25 into 5. So we have 2 times. So into 2 into 2. So we will get minus 2.4 Kelvin. Got it, everyone? Minus 2.4 Kelvin. Right? So it will cool down by 2.4 Kelvin. So 13 हो गया हमारा. 13 में किसको दिक्कत है? देख लो एक बार. 14, 15 भी है. ठीक है, क्वेश्चन नंबर 14 देखते हैं. 13 हो गया होगा. सो क्वेश्चन नंबर 14 देखो. Now ये क्वेश्चन नंबर 14. Forget about bomb calorimetry and all those things. ठीक है, तुम बस देखो कि पूछ क्या रहा है. A sample of benzene C6H6 weighing 6 grams. So यहाँ से तुमको number of moles निकल जाएगा 6 by molecular weight of C6H6, right? Got it? Yes or no? अब molecular weight of C6H6 कितना होता है? Tell me. 12 into 6 plus 6, which is 78. So 6 by 78. Got it? Yes. Was burned in excess in oxygen bomb calorimeter. The temperature of the calorimeter rose from 27 degrees centigrade, 25 degrees centigrade to 38 degrees centigrade. So T1 is given 25 degrees centigrade, which is equal to 298 Kelvin. And T2 is also given, which is 38 degrees centigrade, which is equal to 311 Kelvin. So यहाँ पे डेल्टा टी होगा, राइट? कैलकुलेट करने के लिए डेल्टा टी यूज होगा. ठीक है, चलो नेक्स्ट. तुमसे क्या पूछ रहा है? If the heat capacity calorimeter content was this, what is the value of Q for burning? ये तो सिंपल फॉर्मूला पुटिंग गेटिंग हो गया ना, राइट? याद है कि नहीं फॉर्मूला? N इज इक्वल टू क्या होता है? सही, Q इज इक्वल टू क्या होता है? N C delta T. Yes or no? Tell me, Q is equal to N C delta T. Yes or no? And this is 12.12 kilojoule per degree centigrade, right? So just put the value. N is 6 by 78 into C is given. कितना है C? 12 राइट इनटू कितना है डेल्टा टी व्हिच इज 38 माइनस 25 कितना हो गया 38 माइनस 25 इज 13 राइट बस यही है ना कैलकुलेट कर दूं okay sorry this is heat capacity not specific heat capacity my bad तो 12 जो है वो हीट कैपेसिटी है स्पेसिफिक हीट कैपेसिटी नहीं है ठीक है सो टोटल हीट कितना है ये दिस इज टोटल हीट सो 12 into 13 is 156 and since it is in kilojoule it is kilojoule right so this is total heat per mole कितना हो जाएगा per mole right per mole so per mole it will be this 156 is for 6 grams so it is for 1 mole ठीक है for 6 grams 6 gram means how many moles 6 by 78 moles ठीक है got it right wait this is the energy the heat capacity is capacity है ठीक है so this is the total heat released this is the total heat released okay because यहाँ पे दिया हुआ है बॉम्ब कैलोरीमीटर जो होता है वो कांस्टेंट वॉल्यूम पे होता है तो सिंपली फॉर्मूला तो यही हो गया ठीक है राइट ये हो गया नाउ ये जो है वो 1 मोल है 1 मोल कितना एनर्जी रिलीज कर रहा है 1 मोल जो रिलीज कर रहा है राइट कितना होगा ये टोटल एनर्जी है सो इट इज टोटल बाय नंबर ऑफ मोल्स ठीक है बिकॉज दिस इज योर टोटल एनर्जी ना है कि नहीं दिस इज योर टोटल एनर्जी सी डेल्टा टी बिकॉज इट इज हीट कैपेसिटी ये दोनों मिलाकर क्या होता है सी डैश ना which is your heat capacity it's not specific heat or molar heat capacity याद है ना डिफरेंस specific heat or molar heat capacity or just heat capacity right so for 1 mole it will be total by number of moles now total is 156 by number of moles कितना है 6 by 78 so it will be 156 by 6 into 78 right so this will be the heat for 1 mole yes or no tell me this will be heat for 1 mole yes everyone okay ठीक है now यहाँ पे क्या पूछा 1.25 मोल के लिए so into 1.25 कर दो ठीक है got it so this is for 1 mole for 1.25 mole multiply this by 1.25 1.25 into 156 by 6 into 78 kilojoule ठीक है that would be your answer right everyone tell me सबको समझ में आ गया if you calculate you'll get the answer okay Pranjal yes so this is almost equal to 2535 kilojoule ठीक है got it everyone got this right okay ठीक है everyone got this बता जल्दी से everyone got this okay very good ठीक है so next question number 15 था ना next question number 15 I guess okay ठीक है so हो गया होगा question number 14 let's see question number 15 now ठीक है, सबको देखो क्वेश्चन नंबर 15 everyone. Question 15. Calculate work done on ideal diatomic gas at that undergoes a reversible adiabatic compression. ठीक है, so it is your reversible adiabatic compression. Now what is the information which is given? Pressure is given, temperature is given, volume is given, okay, and final volume is given. Now just think about this. What is the formula for work done? You have to find work done. What is the formula for work? We have solved this kind of problem in examples. So work done is P2 V2 minus P1 V1 by gamma S1. Yes or no? Tell me. Yes or no? Right? So what are the information that we have? We have gamma because it is ideal diatomic gas. So gamma is 7 by 5. Right? Cp by Cv, so 7 by 5. Okay? So gamma we know already, it is your 7 by 5, which is equal to 1.4. Now, what else is given? P1 is given, which is 1 atm. V1 is given, which is 25 liter. P2 not given, but V2 is given, which is 1 liter. Got it? Now, can we find V2? Sorry, P2. Tell me, can we find P2? Because we know that P1 V1 to the power gamma should be equal to P2 V2 to the power gamma. Yes or no? Tell me, yes or no? And this is already given. So I can say that P2 should be equal to P1 V1 by V2 to the power gamma. Yes or no? Tell me, yes or no? So this is P1. Okay, I'll just write the value of P1. P1 is 1 only, so it's fine. V1 is 25 by V2 is 1. Power gamma is 1. Sorry, gamma, right? Just gamma. So gamma is 1.4. 1.4. So 1.4 can be written as 1 plus 0.4. So this can be written as 25 into 25 to the power 0.4. Why? Because this value is given and our total value is also given. So this is exactly, it is given 90.6. So P2 nikal gaya, right? So we have to just put the formula, get the answer. P2 V2. So P2 is 90.6, V2 is 1. So 90.6 minus P1 E1, which is 25. Because P1 is 1, V1 is 25 by gamma S1, which is 1.4 minus 1. So if you solve, you will get the answer. Okay? Got it, everyone? Tell me. Everyone got this? Tell me, everyone. Got this? Yes or no? Right? Just message me. If you got this, just message me. Okay? Right? Okay. No, we don't have time. Okay? Yes. So it will be around 164 liter. Yes. It will be 164 80 meter. Okay? So I hope all of you understood how to find the work done. Okay? All the processes and all those things. Right? So homework is 6.2 homework. And please try to solve all the examples related with thermodynamics of Arsene Mukherjee. Okay? Right, everyone? So in next class, we will start 6.3, which is your thermochemistry and enthalpy. Okay? So most probably this week, we will try to complete this chapter. Next week, we will have some problem solving classes and we will start next chapter. Okay? Because the next topic, it will take 2 days to cover and 2 days for problem solving. Okay? So I hope you are getting everything. Yes, everyone? You're getting everything now? If you have any doubt, please watch the videos again. Okay? Okay. Thank you, everyone. Thank you. Your next class would be from C. I've changed the timings, so please follow that. You will get some time for revision of next class also. Okay. Now, The doubt solving classes will be from 1:45 to 3:15, but the class that was supposed to happen on either Tuesday, physics class, is clashing. The extra class of 11th is clashing with class 12th, so that will be shifted. Okay, so this is just DSS class, extra class. Okay, from 1:15 to 3:15. Your normal class will be from 11:30 to 1, then 3:30 to 5. Okay,